Hi students. In last class we discussed transfer of electrons reactions. Now we'll go to next topic, oxidation number. Oxidation number is defined as the actual or apparent charge possessed by an atom of the element in a compound. The apparent charge is calculated assuming that the shared electrons of a covalent bond belong to the more electronegative atom. See what is the oxidation number means, so that comes in next steps. So before that, how to calculate oxidation number means we have to know some rules. Okay, so we have to know the some rules. So what are that rules? We'll see. So rules for calculating oxidation number. So first rule is in elements in the free or uncombined state. Okay, if the element in free state or uncombined state, that is not combined to any other type of atom, each atom has the oxidation number of 0. Okay, if the element in the free state or uncombined state, its oxidation number is 0. Example: carbon, magnesium, aluminum, sodium all have oxidation number 0. Example: H2, each hydrogen atom has oxidation number 0. Now see in this example, O2, O3, each oxygen atom has oxidation number 0. Second rule, for ions composed of only one atom, monoatomic ion, charge on the ion itself is the oxidation number. Example, if any ions present, so what is the number of charge present on that ion? So that is the oxidation number of that ion. Example C, left side ions present and another side oxidation number present. Okay, example Na plus. What is the oxidation number of Na plus? Plus 1. Cl minus, oxidation number of Cl minus is minus 1. And aluminum oxidation number Al3 plus, so plus 3 oxidation number. Fe3 plus 3 oxidation number. O2 minus, minus 2 oxidation number. So what is the charge present on that each ion? So that is the oxidation number of that ion. Okay, so this is the second rule. This rule is important for finding oxidation number. Example, next one is oxygen. In most compounds, the oxidation number of oxygen is minus 2. The oxidation number of oxygen is minus 2. Okay, but some exceptions. See in peroxides, peroxides means example H2O2, Na2O2. Okay, so this is the example for peroxides. See what is the oxidation number of oxygen in peroxides? Minus 1. Next one, superoxides. Example KO2, RbO2. So this is example for superoxides. In this, oxidation number of oxygen is minus half. You have to remember this oxidation numbers for oxygen. These are exceptions. Okay, next one. Next exception, when oxygen is combined with the fluorine, example oxygen difluoride. Oxygen difluoride, formula is OF2. So what is the oxidation number of oxygen? Plus 2. So only in this compounds oxygen oxidation state goes to positive. Okay, because fluorine is the more electronegative element in the periodic table. Fluorine is the most electronegative element. The second most electronegative element is oxygen. So that's why when oxygen combined with the fluorine, so fluorine is the most electronegative element. So that's why always that is minus. So oxygen become plus. Okay. Next compound, dioxygen difluoride, O2F2. So oxidation number of oxygen is plus 1. You have to remember this compound. So they'll ask in 1 mark question. So what is the oxidation state in oxygen difluoride? You have to remember compound name also and compound also. And in O2F2 also plus one oxidation state. Next, fourth rule, halogens. Fluorine always has oxidation number of -1 in all its compounds with no exceptions, because so fluorine is the most electronegative element in the periodic table, so that's why its oxidation number is -1 only. Okay, there is no exceptions. But in chlorine, bromine and iodine usually have oxidation number -1 in most compounds, but with exceptions. With exception. In oxo acids and oxo anions, Cl, Br and iodine can have positive oxidation numbers. Example, oxo anion ClO minus, that is hypochlorite ion. Oxidation number of Cl is +1. And some more exception, oxo acid HClO4, oxidation number of Cl is +7. Okay, the oxidation number of hydrogen in most. Yeah, next, fifth rule, the oxidation number of hydrogen in most compound is +1 in most of the compound. So hydrogen oxidation number is +1, but some exceptions. Okay, in binary metal compounds like lithium hydride, that is LiH, NaH, CaH2, the oxidation number of hydrogen is -1. When hydrogen is combined with alkali metals and alkali earth metals, the oxidation number of hydrogen is -1. The oxidation number of alkali metals group 1 elements like lithium, sodium, potassium, rubidium, cesium and francium is always +1 in all their compounds. Okay, when hydrogen is combined with alkali metals and alkali earth metals, that is second group and first group in periodic table, in that compounds hydrogen oxidation number is +1. Okay, I have to remember. Next, seventh point, oxidation number of alkaline earth metal group 2 elements beryllium, magnesium, calcium, barium, strontium, radium is always +2 in all their compounds. Okay, so oxidation number of second group elements is +2. You people know already this one. Okay, so oxidation number for second group is +2 only. Okay, eighth rule is, in a covalent bond the apparent charge on the atoms is calculated assuming that the shared electrons are shifted to the more electronegative atom. Okay, so that is eighth one. Ninth one, in a molecule the sum of oxidation numbers of all atoms should be 0. See, in a molecule example you see H2, O2, N2, Cl2, Br2. So what is the oxidation number of these molecules? In this molecule oxidation number should be 0. Next one, 10th rule. In an ion, the sum of oxidation numbers of all the atoms is equal to the charge on the ion. Example, see CO3 2 minus. What is the oxidation state for CO3? So that is 2 minus. Don't take separately. Okay, so complete oxidation number of CO3 is 2 minus. So that is one ion. Okay, so I have to take CO3 completely, that is one ion. Okay, that is oxidation number is -2. Similarly, you can take one more example SO4 2 minus. So what is the oxidation number of SO4 2 minus? So that is -2, like that is completely one ion. Next, calculation of oxidation number with the help of these rules. Now how to calculate oxidation number for particular element? Now we'll see. Before that, steps. What are the steps we have to follow? First you see these steps. After that we'll take some examples. See, steps. Formula of the molecule or ion is written. First you have to write down the formula or ion. Oxidation number of each element atom is written, oxidation number of the atom is taken as a X if it is not known. So which element oxidation number you have to calculate, that oxidation number should be, take it as X. Okay. Now third step, sum of the oxidation numbers of all the atoms is calculated. Okay, sum of the oxidation numbers of all the atom is calculated. You have to add. Next, fourth one. In a molecule, the sum of oxidation numbers is equated to 0. In an ion, the sum of oxidation numbers is equated to charge on the ion. If the molecule is neutral, that equation is equated to 0. If the molecule is in the form of ion, the sum of oxidation number is equated to the charge on the ion. Examples: calculate the oxidation number of Mn in KMnO4, potassium permanganate. Now we have to apply that rules. Okay, see, the given compound is KMnO4. In this KMnO4, that is potassium permanganate, in KMnO4 you have to find out oxidation number for manganese. Okay, so oxidation number of potassium is how much? +1. Why +1? Because this is alkali metal, first group element in periodic table, so that's why +1 oxidation number. Next, oxidation number of each oxygen atom is how much? -2. Okay, second rule. Okay, so you just see the second rule. In that, oxidation number of oxygen is always, in some compounds is -2. Some exception, if it is peroxide, -1, if it is superoxide, -half, if it is combined with fluorine, so that is +1 and +2, that is depends on compound. Now, so in this case, in KMnO4, so oxidation number of oxygen is -2. Okay, let the oxidation number of manganese be X. Okay, so that is unknown. Now then, for KMnO4, now you substitute that oxidation numbers. For potassium, how much? 1 plus manganese is X plus oxidation number of oxygen is how much? -2 into how many oxygen present? 4 oxygen present. So that is equal to 0. Why that is equal to 0? Because that KMnO4 molecule is neutral. So that's why that is equation is equated to 0. Now 1 plus x minus 8 equal to 0. X minus 7 equal to 0. So x is equal to +7. So therefore oxidation number of manganese Mn is in KMnO4 is +7. Okay, so like this I have to calculate oxidation number. Now second example, calculate the oxidation number of chromium, that is Cr, in chromate ion CrO4 2-. See, Cr you have to calculate, right? That one you have to take it as X. So X plus, so oxidation number of oxygen is -2 into how many oxygen present? 4 oxygen present. So that's why -2 into 4 equal to -2. So why this is equal to -2? Because ion 2 minus charge present on that ion. Okay, so that's why -2. Now x minus 8 equal to -2. So x is equal to +6. Now third one, calculate oxidation number of iron in Fe2O3. Fe2O3, 2x plus -2 into 3 equal to 0. 2x minus 6 equal to 0. 2x equal to 6. So x equal to, that is a 6 by 2, that is equal to 3. So why this equation equated to 0? Because Fe2O3, that is neutral compound, so that's why equated to 0. So oxidation number of iron in Fe2O3 is +3 oxidation number. Now fourth one, calculate oxidation number of sulfur in SO4 2-. SO4 2-. Now sulfur is unknown element, so that is unknown oxidation number, so that's why you have to take it as X. So sulfur is X now, plus oxidation number of oxygen is -2 into 4 oxygen present, so that's why into 4 equal to minus 2. Now x minus 2, so that is minus 2 into 4, you will get minus 8. So x minus 8 equal to minus 2 because of that is minus 2 charge present on that SO4. 2 minus is the right, that minus charge you have to take right side. Okay, now x equal to plus, therefore oxidation number of S sulfur in SO4 2 minus is plus 6. Now fifth one, calculate oxidation number of Cl in ClO3 minus. Now Cl is unknown, that is take it as x plus minus 2 into 3 equal to minus 1. So minus 2 is why? Because oxidation number of oxygen is minus 2 into 3 oxygen present equal to minus 1 because charge, minus charge present, right? So that's why I have to take minus 1 right side. Now x minus 6 equal to minus 1. So x equal to 5. Therefore oxidation number of Cl in ClO3 minus is plus 5. In general, metallic elements, that is S block elements, have positive oxidation number. Example Na plus, K plus and Ca2 plus, Mg2 plus. So you know that one. In periodic table, alkali metals are more electropositive element. Okay, so more electropositive elements are S block elements. Next one, non-metallic element, that is the P block elements, have positive or negative oxidation number. Example chlorine, fluorine. Okay, so chlorine, not fluorine, chlorine, bromine and iodine. So chlorine has minus 1 oxidation state and plus 3, plus 1 and plus 5, plus 7 also is oxidation state for Cl. Next one, transition elements, that is D block, have variable oxidation number. Okay, now next topic, stock notation. Transition metals have variable oxidation numbers or oxidation states. To avoid repeated calculation for each compound, a notation was given by the German chemist Alfred Stock. According to this, in the formula of a transition metal compound, the oxidation number of the transition metal is written within round bracket as a Roman numbers. Now, see, in first column, transition metal compounds given, and second column oxidation number given, and third column Stoke notation of the compound they given. Example, you see the transition metal compound HAuCl4. Now you know in this A is the gold, that is unknown element, unknown oxidation number, that one you have to calculate, take it as X, and hydrogen oxidation state is plus 1, Cl is minus 1. Now you know how to calculate. So plus 1 for hydrogen oxidation state, plus, and gold is, take it as X, you have to calculate, and plus minus 1 into 4 fluorine atom present equal to 0. So that time X equal to plus 3. So that is the oxidation number of gold, Au. Okay, so now how to write stock notation of the compound? Now HAu, so what is the oxidation number of gold in HAuCl4? That is plus 3, right? So that one you have to write in bracket after that gold element. Okay, so after Au you just write down that oxidation number in bracket. So that's why HAu and in bracket oxidation number 3, right? That one you have to write in Roman letter number and close the bracket Cl4. Next compound you see FeO. So now what is the oxidation number of Fe in this compound? So I'll get Fe as plus 2 oxidation state. Now how to write in stock notation form? That is Fe bracket 2 in Roman number, close the bracket, and oxygen. Next, Fe2O3 compound, Fe2O3 oxidation number for iron plus 3. Okay, iron has plus 3 oxidation number. Now you have to write stock notation Fe2 and in bracket 3 Roman number, close the bracket, and O3. Now see one more example compound CuI. Now Cu has plus 1 oxidation state in CuI. Now how to write stock notation? Cu in bracket 1 and close the bracket and iodine. Next, last one, MnO2. So oxidation state for Mn as plus 4. So that's why Mn in bracket 4 Roman number and close the bracket and O2. So this is stock notation. Now we'll go to next one. Yes. So next topic is oxidation and reduction in terms of oxidation number. A process in which the oxidation number of an element increases is called as oxidation. Okay, so this is one more definition for oxidation. A process in which the oxidation number of an element increases is called as oxidation. Okay, so next for reduction, you see a process is called process in which the oxidation number of an element decreases is called as reduction. Okay, if any element oxidation number increases, so that element is undergoing oxidation. If the element oxidation number is decreases, it is undergoing reduction. Reactions in which simultaneously oxidation and reduction takes place are called redox reactions. Example, 2Na plus Cl2 gives 2NaCl. Now in this case, see, Na oxidation state is 0. Why 0? First rule you have to apply. Okay, so first rule you see once and take oxidation number of sodium is 0. Okay, why? Because this is free state or it is in uncombined state, sodium. So that's why oxidation number is 0. Similarly, if it is molecule like H2, Cl2, O2, Br2, so its oxidation number also 0. So that's why Cl2 is 0 oxidation number. Now see from left hand side to right hand side, sodium oxidation state is increasing, that is plus, and Cl2 oxidation state is decreasing, -1. Now here sodium get oxidized because its oxidation number increased 0 to +1. Next, here chlorine get reduced because its oxidation number decreased 0 to -1. Oxidizing agent, a reagent which can increase the oxidation number of an element in a given substance. These reagents are called as oxidant. Okay, oxidizing agent, a reagent which can increase the oxidation number of an element in a given substance. These reagents are called as oxidant. Reducing agent, a reagent which lowers the oxidation number of an element in a given substance. These reagents are also called as reductants. Okay, so what is reducing agent and oxidizing agent? See, oxidizing agent, a reagent which can increase the oxidation number, it is also called as oxidant. Reducing agent, a reagent which lowers the oxidation number of an element in a given substance. This reagent is also called as reductants. Next one, types of redox reactions. First one, there are four types of redox reactions. First one, combination reactions. See, the name itself tells that combination. Okay, so combination means two elements combine to form one element. Combination reaction. So two substances combine to form a product. At least one of the reacting substances should be in elemental form. Example, C plus O2 gives CO2. See, two elements combine to form one compound. So that's why this is comes under combination reactions. This is one type of redox reactions. Second one, decomposition reactions. See, decomposition is more what? That is opposite to combination reaction. Okay, so it is the reverse of combination reaction. A decomposition reaction involves the breakdown of a molecule into two or more molecules as products. At least one of the products should be in elemental form. That is opposite to combination reaction. 2KClO3, it undergoing decomposes, gives 2KCl plus 3O2. So this reaction is example for decomposition reaction. See, one molecule is converting into two molecules. Okay, so this is decomposition. Next one, displacement reaction. See, the name itself, displacement reaction. Okay, these reactions involve the replacement of an atom or an ion by another atom or ion. There are two types of displacement reactions. Okay, first one, metal displacement reaction. In these reactions, a metal in a compound is displaced by another metal. Example, CuSO4 plus zinc, that gives Cu solid plus ZnSO4. See, in this reaction, copper, zinc can displaces copper. Okay, so because copper is more reactive than zinc, so that's why displacement takes place. Now in second one, non-metal displacement reaction. The non-metal displacement redox reactions include hydrogen displacement and a rarely occurring reaction involving oxygen displacement. In these reactions, a non-metal like hydrogen is displaced by another non-metal or metal. Example, 2Na plus 2H2O gives 2NaOH plus H2O. Okay, so more reactive, more electronegative or non-metals can displace less reactive non-metals. Fluorine displaces oxygen from water because fluorine is more negative than oxygen. Okay, now 2H2O plus 2F2, so gives 4HF plus O2. So because fluorine is more electronegative element, so that's why it is taking hydrogen from oxygen. Okay, so that's why, so fluorine is more electronegative element, so that's why oxygen is liberated out. Next, disproportionation reaction. This reaction is very important for exam point of view. Okay, you have to remember and read properly. Disproportionation reaction, these are reactions in which an element in a given oxidation state simultaneously undergoes oxidation and reduction. The same element is undergoing oxidation and reduction simultaneously. Okay, you have to remember 2H, example 2H2O2 gives 2H2O plus O2. Here oxidation state of oxygen is H2O2 is -1, which changes to -2 in H2O and 0 in O2. Cl2 plus 2OH minus gives ClO minus plus Cl minus plus H2O. Here oxidation number of chlorine changes from 0 in Cl2 to +1 in ClO minus and -1 in Cl minus. Okay, so this is important type of redox reaction. At least you have to remember one example for each type of redox reactions. Okay, so we'll continue in next class.